right, today we're going to be reviewing for the test on quadratics. This will include the quadratic formula. It will include completing the square, finding zeros and vertices on quadratic equations. First of all, we're just going to solve simple equations with just an x squared and a constant. That's these up here. Even though these look about the same, they're a little bit different each one, and we'll go through each one of these. So on these, all you're going to do is take the square root of both sides of the equation. The key here is don't forget to take the plus or minus. In other words, as I take the square root of both sides of these, this side, the square root of a square is just the number. So it's just x. Equals, and then the square of 16 is 4, but it's plus or minus 4. Now on your, on Alex, it will say, put a comma between the answers. So your answers will look like 4 comma negative 4. Those will be your two answers. Don't leave just one answer. Most kids on this one, they'll do square root of 16, they'll put 4, and they'll think they're done. It's got to be plus or minus the square root of that. So don't forget, there's two answers, plus or minus. Remember, it's the two sides of the x-axis, one at positive 4 and one at negative 4 that you're actually finding. On this next one, we're going to take the square root, but the problem here is you're taking the square root of a negative. If you're taking the square root of a negative, it means that it's imaginary or it doesn't actually work. If you actually punch that into your calculator, it would say no solution. So this is x equals, it would either say no solution or no real answer, something like that. So this is x equals no real solution. So if you take the square root of a negative value, it will be no solution. That's different than putting a plus or minus in front of the square root like we did on this one. Same thing on this next one. We're going to write x equals plus or minus square root of 12. But here, 12 isn't a perfect square. So if it's not a perfect square, you need to factor tree it down and write it in simplest root form or do the decimal value. If they ask for a decimal value of square root of 12, your answer is?
1.011.
Nope. Square root of 12 is like 3 point something. So do square root of 12 and tell me what you get.
Okay. 3.46.
3.46. So it's plus or minus 3.46. Or it might want it in actual form, which means you need to factor tree that down. That's going to be a 4 and a 3. 4 times 3 is 12. And then the 4 would be a 2 and a 2. 2 times 2 is 4. Now remember, when you factor tree down that 4 goes away. Okay? Now I have 2 of the same factor, the 2. Okay? And the 3, I don't have a pair to bring it out with, so it has to stay under the root. That's 2 roots of 3. So my answers are positive 2 roots of 3 and negative 2 roots of 3 on that. If they want actual answers, that's what they'll want. If they want decimal, rounded decimal answers, this is what they'll want. It depends on what it asks for on the test. Okay, the next one is a little bit different. We're going to have a quantity squared, a parenthesis squared, and you're going to be asked to solve this. Now on this one, you want to get the quantity squared by itself. That's the key. Again, let me say that again. Get this quantity, this parenthesis that is squared, by itself on one side of the equation. Then take the square root. Those are the two basic steps. So I'm going to subtract 5 from both sides. 25 equals x minus 3 squared. I then take the square root of 25, which is 5. Again, don't forget that you're really getting two answers. The positive square root of 25, which is 5, and the negative square root of 25, which is negative 5. Now I'm going to add 3 to both of those. So as I do this, my two answers will be positive 5 plus 3. What's positive 5 plus 3? That's 8. Negative 5 plus 3. That's negative 2. Those are your two answers, and that's how you'll write them in Alex. You'll put a comma between them. Next one's going to ask you to tell me what goes in this blank by completing the square. Okay, tell me what goes in that blank by completing the square. This will be an even one, so it'll be easy on the test. So this will be even. Okay, so all I do is I take and complete the square. To complete the square, I have to take half of the linear value and then square it. That's what's going to go in that box. Again, half of the 8 squared is what goes in that box. So I'm just going to do the math. Half of 8 is 4. 4 squared, a lot of kids think that's 8, but it's really 16. Okay, so that's what goes in that box. Again, take half of the number in front of the x square it, and that's what goes in the box. Okay. The next problem is going to say solve by completing the square. Again, fairly easy here. I'm just going to add 11 to both sides, and this is kind of the key to completing the square. You have to get the quadratic and the linear on one side of the equation, and then the constant on the other. When you're completing the square, do not try and set it equal to 0 like this was originally. You actually want the quadratic and linear on one side, and then the constant on the other. When you're doing quadratic formula, which we'll go on to next time, we do want it equal to 0. So that gets a little confusing. When completing the square, okay, we want to have the quadratic and linear on one side and the constant on the other. When we're doing quadratic formula, we do want it equal to 0, and I'll do that one next. But for this one, we want it like this. Now I just simply take half of 6. That's pretty easy. Half of 6 is 3. Square that value. Now here's where it gets tricky. X squared plus 6x plus 9. I got 3 squared is 9. A lot of kids forget that you have to add 9 both to the left side of the equation and the right. So I've got to add 9 to 11. 9 and 11 make 20. Now this side is a perfect square trinomial. That's why we complete the square. Notice this is a perfect square, that's a perfect square. Okay? And the square root of this, doubled, is that middle term. So this will make one set of parentheses squared, much like this question up here. Okay, this question up here now becomes a lot like this question. To do this, I just take the square root of the first term, x, square root x, sine of the middle, plus square root of the last term, 3. Okay, again, square root, sine of the middle, square root. Put it in one set of parentheses squared, that's a perfect square trinomial, factored into a binomial square. Equals 20. That's why we complete the square, so we can get there. Now I just take the square root of both sides. Again, we're going to have two equations. We're going to have x plus 3 equals square root of 20. And we're also going to have x plus 3 equals negative square root of 20. Now I have to say, all right, this is either going to ask, hey, I want it in decimal answers, or it's going to ask you to do it as in radical form, or exact form, exact radical form. So I'm going to do it both ways. To solve this, I would just simply subtract the 3, and my first answer would be negative 3 plus, and then this square root of 20 I can factor tree to a 4 and a 5, 2 and a 2. Again, remember that 4 goes away. I bring out the 2 roots of 5. Okay, so that's if it wants exact form. Same thing here, I'd subtract the 3, x equals negative 3 minus 2 roots of 5. So if it wants exact form, that's your two answers. If it wants decimal form, the square root of 20 is actually 4.47. So I would take negative 3 plus 4.47. That's 1.47. And then I would take negative 3 minus 4.47. That's going to be negative 7.47. So those are your two answers. Okay, if it wants it rounded to the nearest hundredth, which it probably will, or it could say, give me exact answers like that. Depends on the problem, what it asks for. So pay attention to that. If it says round to the nearest hundredth, boom, these are your answers. If it says, hey, I want it in exact radical form, these are your answers. Depends on how they ask it. Okay, now doing quadratic formula up here. Quadratic formula is going to be done to solve these using the formula that you have on YouTube. So you can rewatch that video where the guy stabs him in the head. It's quite interesting and enjoyable, I'm sure, for all. As you watch that, it kind of gives the quadratic formula song so you can remember it. And if you remember that song, it says we have negative b plus or minus the square root of b squared minus 4ac over 2a. All right, you can remember that song. It's nicely done there, but handsome. All right, so now we're going to just plug that into this equation. So we're just using these values for a, b, and c. So the first value is a. the number in front of the x squared. The second value is b. That's the number in front of the x. The c value is the last value. It must be equal to 0 to solve with the quadratic formula. You have to set this one equal to 0 to solve for the quadratic formula. Now I just plug in those values. So I have opposite, so notice this is negative b, so that means the opposite sign of b. So this was negative, so it now becomes positive 6, plus or minus, square root of. Now we're taking b squared, so negative 6 times negative 6, a negative times a negative is a positive 36, minus 4, that's that 4 right there, times a, times c, all over 2 times a. Okay, so again, I followed this formula. The a value is 10. The b value was negative 6, so opposite of negative 6 gave me positive 6. B squared, negative 6 times negative 6 equals 36, minus 4ac, minus 4 times the 10, that's the a, times negative 3 is the c. Make sure you keep your signs in there. Now I have a negative times a negative, which is a positive. 4 times 3 times 10, 4 times 3 is 12, times 10 is 120. Now I have the square root of 120 plus 36, 156. Now on this one, I'm pretty sure on the test, it asks for rounded to the nearest hundredth. So I want to just punch that into my calculator, square root of 156. You know it's a little more than 12. Your answer will be? 12.489. 12.489. So I'm just going to round that to 12.49. Okay? So now I have 6 plus 12.49, that's 18.49, divided by 20. Don't forget to divide by 20. A lot of kids do. You have to divide that by 20, and you'll get a decimal value. What'd you get? 18.49 divided by 20.
0.924.
So this equals 0.924, so it's 2 decimal places. 0.92 is one of your answers. Then you have to subtract. So now I do 6 minus 12.49. That's going to give you positive 6.49 divided by 20. 6.49 divided by 20 will give you 0.32. Those are your 2 answers. Remember, these answers represent where the graph is crossing the x-axis. So it crosses it at 2 spots. This one is only like really close together. So if you think about it, here's your x and y axis. 0.92 is like right there. 0.32 is right there. It's opening up. So you know it's going up. It's going right through those points, really steep. So that's what that one's going to look like. But those are the points that it crosses that x-axis. All right, which brings us to the next question, which is where we're going to talk about, hey, when's it going to hit the ground, things like that. We're going to have a rocket launch from the ground, and it's going to be launched at 112 feet per second, which gives us this equation. The reason that the negative 16 is there is because we have gravity pushing down on it at negative 16 feet per second squared. So now, this is the equation of our rocket launch. Remember when we launched the paper rockets? This is basically what we were doing. This is actually pretty close to the equation that we were doing too, because that's about 25 pounds per square foot. Only this is launching from the ground directly. We were launching from a little bit higher than that because of our rocket launcher. It was about 3 feet off the ground. All right, so anyways, we're just going to solve this though. So we're going to find the amount of time it takes to hit the ground, and then finding the maximum height. Those are the 2 values we're going to try and find on this one. So first of all, when will it hit the ground? So think about this. The height of t, the height over time, equals negative 16t squared plus 112t. So what's the height when it hits the ground? 0, right? It's not off the ground at all. The height is 0. So I'm going to set this equation equal to 0 to solve. Negative 16t squared plus 112t. Now what makes this a little bit difficult is this negative 16. If I can get rid of that, that would be nice. So what I'm going to do is I'm going to divide everything by negative 16. Okay? 0 divided by negative 16 is 0. Negative 16 divided by negative 16 is t squared. 112 divided by negative 16 is, 112 divided by negative 16 is negative 7.
Yep.
Okay, now we're going to factor this. Now this is one I can just factor. Could you use quadratic formula? Absolutely. But that's going to take you a lot longer. So the easiest thing to do is just factor out the common factor. What's the common factor between t squared and negative 7t? Well, that's just t. So I have 0 equals, and then I have t times t minus 7. Now t is 0. That's the time it was launched. Think about it. The rocket's being launched from the ground. As it's launched from here, that's at 0 seconds, it's launched. And then it goes up, and then it comes back down. When's it going to come back down to the ground? T equals 7. Again, t minus 7 equals 0. Add 7 to both sides. After 7 seconds, it's going to hit the ground. So think about that. Launched from here, goes up, reaches its maximum height, comes back down 7 seconds later. Creates that parabolic arc we were talking about. Okay, now, here's the big issue. When will it reach its maximum height? When will it reach its maximum height? Well, that's the midpoint between these two. Between 0 and 7 seconds, that's when it reached its maximum height, obviously. So the maximum height is the midpoint between these two. That's key on the test. So the midpoint between these two is what? Is 3.5. There's another way you can do that if you forgot that. You could simply take the b value, 112, divided by 2a to find the x-coordinate of the vertex. That's what we're going to be doing in the next part anyway. So we take the b value, 112, divided by, so this is b divided by 2a. Okay? And that's going to give you your vertex point. Oh, sorry, negative b over 2a. Sorry, negative b over 2a. So in this case, it's negative 112 over 2 times negative 16, which is negative 32. Again, you can do that on your calculator. Do 112 divided by 32. And lo and behold, you get
Negative 3.5.
3.5. Well, we have a negative divided by a negative, so it'll be a positive 3.5. So either way, you'll get 3.5 there. That's your x value. That is not your maximum height. That's the amount of time it takes to get to the maximum height. So you got to plug this into the equation. So now I write, all right, I want to find h of 3.5. Saying, I want to know the height of this sucker, of this rocket, after 3.5 seconds. So I'm going to plug in 3.5 seconds. Negative 16, 3.5 squared, plus 112 times 3.5. So we're going to do this on the calculator. We're going to do 3.5 squared times negative 16. That's the first thing we're going to do. And that gives us what?
Negative 196.
196. Okay? Then we're going to take 3.5 times 112.
392.
392. Now I'm going to subtract those, 392 minus 196, and the height after 3.5 seconds of this rocket was
196.
196 feet. That's the maximum height. So if you think about that, and if I wanted to do a graph of this, I don't have to do a graph on this one, but I'm going to because I think they're fun. So I launch at 0 seconds, right? And it goes clear up in the air. It's going to be marked as seconds in the air, right? 1, 2, 3, 4, 5, 6, 7. What's going to happen at that 7th second? Well, we just found out that it's going to hit the what? It's going to hit the ground. So we're back here. We went up, we came down. At 3.5 seconds, 1, 2, 3.5, we went clear up here. And what point were we at 3.5? We were at 196 feet. So this is 3.5 seconds and 196 feet above the ground. And then it came back down and hit the ground again at 7 seconds. So this is 7, 0. This is 0, 0. This is when it was launched. This is when it came back and hit the ground. That was the maximum height. That's what it represents on a graph. Now, it doesn't ask you to graph it. I just thought it was cool to graph it. So it'll ask you this, though. Find the amount of time till it hits the ground and find the maximum height. Okay, that brings us to graphing, though. That's why I wanted to show that. So now we're going to do some graphing. Okay, here we go. It will give you a graph on Alex, and it will ask you questions about that graph. It will say, does the graph open up or down? What are the x and y intercepts? What's the equation of the axis symmetry? What's the vertex? Very simple, actually, because they already give you the equation. They already give you the graph. So all you got to do is look at the graph. Okay, does it open up or down? Well, obviously, that graph is opening what? Down. So that's the answer. Okay, x and y intercepts. That's points that it crosses the x and y axis. So the x-intercepts are where it crosses the x-axis. Where does this cross the x-axis? Well, it crosses the x-intercepts equals -1, because that's where it's crossing. And then I look here, 1, 2, 3, and 3. That's where it's crossing. So my answers for x-intercepts are -1 and 3. Very simple. Y-intercept. It will only have one of these because it only crosses the y-axis at one point. So I'm going over 1, down 2. That's from this top point. Now I better find what this top point is anyway, because I'm going to ask the vertex next. So we went over 1, we went up 1, 2, 3, 4, 5, 6, 7, 8. So this is 1, 8 for my vertex. I went over 1 and down 2 is where I hit that. So I'm going to say my y-intercept is up 1, 2, 3, 4, 5, 6. So there's my y-intercept. The vertex I just found, it's at 1, 8. Now the equation of the axis of symmetry, remember like when we played war in class? We would fold the paper and then it would match up. So think about having a paper folded right along that axis of symmetry. What is this line equation? Well, it's x always equaling 1. So our axis of symmetry is the x value always. X equals 1. Okay? Now we're going to do the graph of an equation. So they're going to give you the equation, they're going to ask you to graph it. How do you graph it? Easiest way is -b over 2a to help you find the x coordinate of the vertex. Plug that value in to find the y coordinate of the vertex. And then just use this scale factor of 2, which is what we're going to do. Okay? So we're going to do -b over 2a, that's pretty easy. 8, opposite value of that value, over 2 times a. 2 times 2 is 4. 8 divided by 4 is 2. So we know the x-coordinate, remember this is the x-coordinate of the vertex, will be 2. Now I plug that in to find the y value of the vertex. So y equals, notice the equation is the same, y equals 2 times 2, that's where that 2 came from, squared minus 8 times 2, I'm plugging in that 2 for x, plus 10. Square that out. 2 squared is 4. 4 times 2 is 8. Minus 8 times 2 is 16, plus 10. 8 minus 16 is -8, plus 10 equals 2. So on my graph, I'm going to go to 2, 2. Okay? That's where it should start. Now, this graph tells us by this scale factor that it's going to open up because that a value is positive. If the a value is positive, it opens up. If the a value is negative, it opens down. Remember on the previous equation, it had a -16, so it opened down. Here we have a +2. This one's going to open up. Okay? So now I follow the scale factor based upon my parent graph. Remember, xy of y equals x squared. So x is plus or minus 1, this is 1. Plus or minus 2, we square it, 4. Plus or minus 3, we square it, 9. But these have to get multiplied by whatever that a value is. So in this case, the a value is what? 2. So these got to get multiplied by 2 to create other points. So I've got to go from the vertex, which was 2, 2, I've got to go to the right one and left one and up 2. So this is what I'll mark on my Alex assignment. I'll mark those 2 points. So this point is 2, 2, but then I'll mark 3, 4, and I'll mark 1, 4. Then I'm going to go over, normally 2 and up 4, but I got to times that by 2 again because of that a value. So 4 times 2 is 8. So I've got to go from the vertex over 2 and up 8. You'll notice that over 2 and up 8 on this one, 1, 2, 3, 4, 5, 6, 7, 8, sorry, over 2, up 1, 2, 3, 4, 5, 6, 7, 8, sorry. And I end up with 0, 10. Now that makes sense because the y-intercept is at 10. And then obviously it's symmetrical, so if I go over to 4, notice 2 is to 0 is 2 away, 2 to 4 is 2 away. If I go to 4, 10, I'm going to be at the symmetrical point. And then I can just use my graphing tool on Alex to mark that graph up. So again, let me review that one. That was a hard one. To graph this, you have to do negative b over 2a to get the x coordinate. So opposite of 8 is, or the opposite of negative 8 is 8. Over 2 times 2 is 4. That's how we get that 2. I then plug in that 2 for x to get the y value. It also happened to be 2. So then I mark my vertex at 2, 2. I use my scale factor, which is the a value, to go from the vertex over 1 and up, whatever the scale factor is, times these parent graph values of 1, 4, 9, 16, all the perfect squares. So I go over 1, up 1 times 2, which is 2. That's how I got to 3, 4, and 1, 4. And then I go, instead of 4, 4 times 2, again, because of that 2 value, 8. So from 2, 2, I go over 2 and up 8. That puts me at 4, 10. And I go over to the left 2 and up 8. That puts me at 0, 10. That's how I got my graph. Okay, let's go over here. We're going to find the vertex and the x-intercepts is all. So this one I don't have to graph, but I just have to find the vertex and the x-intercepts. The process is the same though. To find the vertex, again, negative b over 2a. So this one I'm going to have opposite of negative 4 is positive 4 over 2a. 2 times 1 is 2. That again is going to give me a 2 for my x value. Plug in the 2. 2 squared is, so I have y equals 2 squared minus 4 times 2. If you'll put parentheses when you substitute, you won't mess up signs. It's a lot better. And then minus 32. So 2 squared is 4 minus 8. 4 times 2 is 8 minus 32. So that's going to give me negative 4 minus 32 is negative 36. Okay? So that's my y value. So what is your vertex on this one? It's going to be 2, negative 36. That's your vertex. Then it says, hey, what are your x-intercepts? Well, a couple different ways I could find my x-intercepts. I could just follow it by a graph, but I don't like doing that. The easiest way is to just factor it. So think about factoring this, reading it backwards. What times to be 32 and subtracts to be 4? Think in your head. What times is to be 32 and subtracts, that's because of that sign, to be 4. What multiplies to be 32 subtracts to be 4. Okay, well those are 8 and 4. 8 times 4 is 32. 8 minus 4 will be 4. So now I put my signs in. If it's a difference, the signs are different. The bigger one gets the negative. So it's going to be x minus 8. Again, if it's a difference, the signs are different. The bigger one gets the sign in the middle. So in this case, it gets a negative and a plus there. Set this equal to 0. What are my zeros then? So your x-intercepts, that's what it's asking for, are, set this equal to 0 and solve, negative 4, set this equal to 0 and solve, positive 8. Those are your x-intercepts. Those are where it's going to cross the x-axis. Okay, next question. On this one, on this equation, what would the minimum, would it be a minimum or maximum value? What is the minimum or maximum value? And where does this minimum or maximum value occur? Really all this is asking for is the vertex, okay? And then whether it opens up or down. The a value tells you whether it opens up or down. So because that's negative, it's going to open down. So think about this. It looks like that. It's opening down. Is this a max value or a min value? Obviously, that's a max. So right away, I'm going to say, hey, I know I'm talking about a max here. And so now what is the max value? Well, this is finding the vertex. So I'm going to again find the vertex by taking opposite of 10, negative 10, over 2a. A is negative 5. Keep the sign with it. Okay? What's 2 times negative 5? Negative 10. What's negative 10 divided by negative 10? Well, this is 1. So 1 is the x value. That's the value I need to plug in to find y. So I'm going to say, all right, I want g of 1, which equals negative 5 times 1 squared plus 10 times 1 plus 1. All right, 1 squared is 1. 1 times negative 5 is negative 5. 1 times 10 is 10. Plus 1. 10 minus 5 is 5. Plus 1 is 6. So what's my vertex point? So your vertex is 1. That's the x value. 6. That's the y value. That tells you everything you need to know. What is the maximum minimum value? That's always the y value. That's the highest it'll ever get. So this minimum or max value is 6. Where does the maximum value occur? At x equaling, this is the x value, 1. So where does it occur is the x value. What is the max or min value is the y value. That's super important. The y value is what is the max or min value. The x value is where it occurs. Okay, last question. Cost to build a car is given by this equation at a Ford plant. So we're building like Ford Focuses or something like that. So let's say you're building a Ford Focus. You're at a Ford Focus plant. You want to maximize profitability. Now obviously buying all the equipment and starting up a plant is going to cost you more money if you're not producing any cars. So that's not going to maximize your value if you're producing 1 or 2 cars. But if you produce a whole bunch of cars, but all you have is that equipment to produce them, the only way you're going to produce more is to have more people hired, and eventually the cost of the people outweigh the cost of the car. So you got to figure out what is going to maximize your limited cost of each car. So that's what we want to find. This is actually a quadratic equation that tells us how we're going to find that minimum value. So it says, what is the minimum cost to build a car, and how many cars would be built to create the lowest cost, thus maximizing the efficiency of the plant. People get paid millions of dollars to simply play with these sort of equations, to be able to tell the business, how many cars should I make in a month that is going to maximize this plant's cost. So that's what we're doing, okay? So it's not that hard though, because really all you're doing is finding the vertex point again. Remember, the minimum value is when you drop down to the very lowest point. So I'm just finding the minimum value by finding the lowest point. I'm finding that vertex point. So I'm going to just plug in negative b over 2a. Have you noticed we've done this about 1,000 times on this review? That's going to be the key to the entire test, honestly, is doing negative b over 2a. Anytime it's asking for a vertex point. So I do 96 divided by 2 times 0.6. Don't forget your decimal there. 2 times 0.6 is 1.2. Now I need to do this on a calculator. 96 divided by 1.2 is 80. That is my x coordinate. That's my x value. We'll talk about what that means in a minute. But we need to plug that in to find our y value. So I'm going to put C of 80, the cost of 80 cars, by the way, is what that's saying, would be what? So I'm going to say, okay, I got 0.6 times 80 squared minus 96 times 80 plus $12,000 a car for startup costs there. All right, so this should minimize our costs. Let's see what we get. 80 squared is 6400 times 0.6. Do 80 squared times 0.6, and what do you get? 80 times 80 times 0.6. You can do it that way too.
166,400.
160, I don't know. Do 80 times 80 times 0.6 and tell me if that's right. Times 0.6.
3,840.
Okay, that sounds better. 3,840. I was like, that sounded a little big. All right, so 3,840. Okay, now I need to do 96 times 80. That's going to be 70 something. 7,000 something.
7,680.
680 plus 12,000. Well, 3840 minus 7680 is going to be negative 3840. Plus 12,000, sorry. Okay, so 12,000 minus 3840. 12,000 minus 3840 is?
8,160.
So the cost of making 80 cars is going to be, say that again?
8,160.
$8,160 a car. So that tells us everything we really need to know. What is the minimum cost to build cars? The minimum cost is going to be $8,160. That's how much it costs to build a Ford Focus. Okay, now think about that. If I doubled that, $16,000, that's what they're going to sell the car for. They're trying to make a profit, obviously. How many cars being built would actually make the lowest cost, thus maximizing the efficiency of the plant? Well, that's this 80 cars a month. If I make 80 cars a month, that's going to be the lowest point on my curve. So I want to actually make 80 cars every month at that plant, thus lowering the cost per car to $8,000. That's when I'm going to make the most money. What happens if you make, I don't know, say 70 cars? Well, then obviously it's going to cost you more per car. What if you make 90 cars? It's going to cost you more per car. So you don't want to make that. You want to make exactly 80 to put the cost per car at its lowest value. That's how you make the most money in business. And that's why people make tons of money doing this as a business actuary and actually doing math all day. You can do math all day. I'm sure you'd love that. Thank you.